Hello and welcome. A couple of weeks ago, some folks were asking me what I'm using for developing with Crystal on my local environment. And honestly, I'm not developing locally with Crystal. I'm actually using container images to run my applications, my development environment. And the benefit of using that is that I have a reproducible environment that I can run in multiple constraints. And if I have to um, extend it to include additional tools, I can go and iterate from that image and extend it with the specific things. Of course, there's people that will say there's other tools like Nix, but I'm not that fun or that familiarized yet with that, right? So I'm using container images based it on a Docker file. I'm building Crystal from source and cross-compiling because this image that I'm using, this project is called Hydrofoil, that you can actually go and check it out on GitHub. And Hydrofoil, the whole idea of is just an opinionated Alpine-based Crystal compilation. So I'm building Crystal for ARM64 and for AMD64. So it's compatible with Intel and ARM processors. I'm using an existing compiler to cross-compile for those targets and then putting all the structure and then the specific utilities that I'm using on local development, right? Because I'm using this for development. And those utilities are mostly two tools. One of those tools is Overmind in order to run Procfile-based multiple processes within the container just for development. That allows me to have like a server specs or things like that all running at the same time when I boot up the container, and then watch exec to detect changes and then be able to run based on those changes. I'm following kind of like an a POSIX Unix approach where I'm trying to use one single tool for one specific job and then combining those tools in order to obtain what I want, instead of having like a tool that does everything under the sun for you to do things, right? I find it more efficient to use one tool. Then you can go and take a look to that and now see how like within a massive tool that does a bunch of things, how they work. So the Docker file is just building those kind of things, and how I'm using it locally. I can go basically to this Docker Compose example where I'm defining a service. I call it app, and then I define the image. In this case, I'm going to depend on Crystal 1.7. I could be specific and say 1.7.3 or zero point 0.2 because I'm building those specific images. And then I'm running Overmind for the command to boot up with a Procfile for development, and then making sure that I mount the volume with my local source code as the app directory, making the work in their app directory. And since I'm running in a rootless kind of containers, I'm using a non-root user. So I need to pass what is the user ID and the group ID of my local user in order for the files that are generated are actually owned by my current user and not by root, and then generate some permission issues on your development. If you're not familiar with that, you're lucky. But at the beginning, when people started using Docker and running things as root, it became source of a lot of problems, right? And then when I call here Overmind to run the Procfile, the Procfiles might be different because for those who are not familiar with Heroku, which is the one that kind of like defined this process file kind of a structure. You define a name of a process. In this case, I call it autospec, which I'm going to be using watchexec to detect changes on the source or spec directory for all the files that are .cr, which is the Crystal extension, and then it's going to run Crystal spec as command when it detects those changes, right? This is one example. But I can also do one that run a server, right? When it detects changes for source files, it uses charge run to run a process. And when it detects those changes, it can actually terminate the process and start again, similar to shotgun in the Ruby world, when you detect the changes on your files and kill the process and start a new application, right? When you're dealing with compiled languages and detecting the reload of changes, this works great for that. And the other specs, of course, it will give you that instant feedback. So when I built this, the crystal image for Alpine didn't exist or wasn't as optimized as today. Today is 400 megabytes. The hydrofoil crystal image is 350. There are 50 megabytes of difference. It's not as much, but it contains the tools that I want and in 50 megabytes less. So that, and also some optimized layers. How I'm using that, like for example, on the Radix shard that I built, I'm actually going to boot up the container, and that automatically starts the AutoSpec process. And if I touch my source code, what it's going to do is going to launch a compile in the end, like a crystal spec to be run, and it automatically runs, and it gives you that feedback loop for you to monitor. So in the case that I'm running this in a terminal side by side with my editor, I can have immediate feedback as I start writing my specs or my test for my project, right? And in the case of the executable that I was mentioning before, if I do compose up, it's going to do short run, which actually builds the executable and executes the executable. And in this case, you see listening on port 8080, and I'm going just to do a curl to localhost port 8080, and I get a random name. That's a project that I used before. But if I touch the server file for it, is going to try to recompile that, right? And it's going to find the dependencies, build the executable, and launch it again. And I try it multiple times and does that automatically, right? There you can see it builds and it runs multiple times. And that's how I use it locally. And why I decided to use this as an Alpine is because I wanted to build static binaries for CLI tools and actually for my applications. So I don't have to distribute a bunch of dependencies, or I don't need to care about what is the version of the server this is going to be run. So a little executable that is static. It doesn't depend on anything that is installed on your machine, and can run independently. If I deploy this to a Fedora server or a Fedora machine or an Ubuntu machine or Debian or whatever is the distribution, it should run without issues. That gives you that flexibility. And I use this for local development because I don't have Crystal installed locally. So if I go and I do Crystal version, I don't have it. All the things that I have are within the container that I was showing to you. So that's all. Kind of like how I'm using it. It might not be practical for some, but I wanted to have like more reproducible environment for those kind of things. Always trying to have a parity between what I'm using in local development versus what I'm going to be targeting to my release. And since I'm on my release, I'm going to be building that static binary, then I can go and ship it using those versions, right? The same ones that I used during development. So for example, if you're running on Mac OS and you're developing things locally, you cannot build static binary, generally speaking, that can run on any other Mac. But also you also have a difference is that if you're running on Mac OS natively, and you're targeting to a Linux server, you're going to have discrepancies on how things work, right? Not most of the time, but there are caveats and there are like differences that you need to take care of. So with that in mind, I wanted to reduce as much as possible all those differences to the environment that I'm targeting on. So that's kind of like the explanation on why I'm doing it the way I'm doing it. Some people might find that weird, some people might find that interesting. So I hope if you're in the side that you find it interesting, just let me know. If you wanted to see more how I'm using that, just let me know. Wish you have a great day, and thank you for your time. Bye.